Today, our purpose statement is to explain and describe the transformations of polynomial functions. Now, this is your last assignment for 2015. I'm going to go over it fairly quickly because it should be familiar to you. We've already done transformations with absolute value, and we did it with quadratics. The only difference now is we're doing cubic, and nothing changes. So I'm not going to give you an assignment on this as so much as I'm going to put some extras of these into the practice test that you're going to get today, so that you're ready for that test this week. So, transformations. If you remember, vertical transformations, if it's vertical, then it happens outside x, or to the whole function. So when we have this, whatever our function is, f of x plus 6, let's say that our f of x is x cubed. Then the k would be, we'd add 3 to the function, so it would be 3 units up. Or if it's minus 4, it's 4 units down. Remember, that's always added or subtracted to the whole function. Whereas if it's a horizontal translation, then it happens inside, and it's always the inverse of what it says. So when it says, again, our x cubed, if it says x minus 2 cubed, then it's 2 units to the right because it's the inverse of what it says, so the inverse of minus 2 is plus 2. If it says plus 1, then it's 1 unit left. So a vertical stretch or compression, again, it happens outside, so it affects the whole function. So it would be 6x cubed if it was a stretch of 6, or if it says 1/2 x cubed, it would be compression of 1/2. If we did that inside, again, remember, it's the inverse of what it says, so since it's multiplied, the inverse would be the reciprocal, or multiplicative inverse. So if it says 1/5 x cubed, again, it's inside, so it's the inverse. So the inverse of 1/5 would be 5, and so that would be a stretch. Remember, stretches are greater than 1, and compressions are between 0 and 1. If it says 3x to the cube, again, it's inside, so it's horizontal. We take the inverse of 3. Since it's multiplied, it would be the multiplicative inverse, or reciprocal would be 1/3. And since it's less than 1, that would be a compression. Reflections, again, if it's vertical, so over the x-axis, it affects the whole thing. So negative x cubed would be a reflection across the x-axis. And if it's a horizontal reflection, it's over the y-axis. And so it happens inside, so it would be negative x cubed, which would be across the y-axis. So today you're going to have 3 basic types of things that you have to do. The only difference between when we did this with quadratics, it's just going to be a little bit more complicated. So let's say that our f of x is x minus 5 cubed plus 3. So let's say that they ask you to do a vertical stretch of 5, and let's go 4 up. All right? So if we do the vertical stretch of 5 first, remember that affects the whole thing. So that's like writing it f5 of f of x. So that would be, I'd multiply this by 5, and so it would be 5 x minus 5 cubed plus, now here's where people make mistakes, it's 5 times the whole function, so that would make that 15. And then we're going to go up forward, so now we're going to take this and we're going to add 4 to it. So it's f of x, 5 times f of x plus 4. And so that would be 5 x minus 5 cubed plus 19. All right? So that would be one example. Let's take the same function. And let's say that we, let's horizontal translation of 7 to the right, and vertical translation of 6 down. All right? So horizontal, remember, it happens inside it, so it affects the x. So that's like doing f of, we're going to go x to the right, so -7. And then we're going to add, subtract 6 from this. And so now when we plug that in, remember we're putting x minus 7 in for x. So we get x minus 7 here, minus 5, which would be x minus 12 cubed. And then we're going to take 6 and subtract it from 3, and so we get minus 3. And so that would be our new function. So one thing they're going to do is they're going to give them to you in words and have you write the equation. The other thing they're going to do let's take a new one. Let's take x plus 7 to the 7th minus 4. Now these powers don't make, they can be any exponent they want. It doesn't change what we do. So let's say that we go 2 f of x plus 5. So they're going to ask you to write your new function g of x. So they're going to say g of x equals this. And we're going to have to write that new g of x and then explain the transformations. So if we look at this, this says we're going to take 2 times this whole thing. So we get 2 times x plus 7 to the 7th minus 8. And then we're going to add 5 to it. So our final answer would be 2 times x plus 7 to the 7th minus 3. And so the description would be, what do we do here? The multiplying of 2 is a vertical stretch of 2, and the plus 5 is a vertical translation. Now again, you can put translation, shift, or slide. All those terms work for this. Translation, and it would be up 5. Okay? So let's do one more of this. So they're going to give you this, give you an equation. You're going to have to tell the new what g of x is. This is our final g of x. And then describe in words what's happening. So again, because it's multiplied by 2, it's greater than 1, so it's a stretch. And then it's adding 5. So let's do one more of these. And let's say that they're going to g of x equals negative 1/5 x, or f of x, f of x minus 3. Okay? And let's add plus 7. All right? So, we got to take negative 1/5 times this whole function. But we got to put x minus 3 in here for this, because we're going to move it 3 to the right. And then we have the plus 7, so x minus 3 plus 7 to the 7th minus 4, and then we have to take this 1/5 to the whole thing. So we get negative 1/5 x, and minus 3 plus 7 becomes plus 4 to the 7th. And then negative 1/5 times negative 4 is a positive 4/5. And then we're going to add 7 to that. So negative 1/5 x plus 4 to the 7th plus 7 and 4/5. So this one's really complicated. If you just take it slow. So the negative sign does what? The flex over x-axis. The 1/5 is a vertical compression of 1/5. Now, some of you like to put the negative sign there, but remember it's the absolute value for stretches and compressions, so we don't worry about the negative sign in there. And then it's a vertical translation of 7. Now you can put 7 up, or you can just, since we said vertical, we know it's up or down. So if you want it down, you can put minus. So you can put 7 up 7, or just vertical translation of 7. And then if you did negative, you would do a vertical translation of -7. So any of those. So again, going over this, you take -1/5 times the whole thing times the whole function, which is here. So we take -1/5. It stays outside the parentheses. We don't distribute it inside because we have to do the power first. So -1/5, x plus 4 to the 7th. -1/5 times -4 is a positive 4/5. And then we have to add the 7 at the last part. And so we get plus 7 4/5. So that's the second thing you're going to do. Is you're going to be given a function and then be given what g of x is as an equation, and then have to tell the new function and describe the transformation in words. And then the last thing that you're going to do, which we haven't done before, but hopefully is fairly easy for you, they're going to give you a graph So let's go here. And they're going to ask you to do a transformation on this and rewrite the new graph. So as an example, translate 3 to the right and translate down 2. So they could write it in words, or they could say, let's say f of x is the graph. Find g of x, graph g of x, which is x minus 3. Actually, they put, which is f of x minus 3 minus 2. Okay? So they can write it either way. All it tells you to do, the minus 3 or 3 to the right, says we're going to take points and move them 3 to the right, and we're going to also move them 2 down. So what you want to do is just pick points that are easy, like our turning points. So 3 to the right would be 1, 2, 3. So that would be there. Let's change colors. So that would be there. And down 2. So it would end up there. So that's our point. And I'm going to take this point and move it over 3 and down 2. So it's going to end up there. And now let's take this point, move it over 1, 2, 3, and down 2. So these are just approximations. And let's take this point and move it over 3, 1, 2, 3, down 2. And let's take this point and move it over 3 and down 2. And so our graph, I just connect those dots now. And I'm done. So you just pick points on the graph. You want to take the turning points and then just other points that make it easy for you to connect it. And again, it's not going to be perfect, but you can see it gives the idea that we know it's shifted over 3 and down 2. And that will be your graph. So there'll be a problem of this type also. So those are our 3 types of problems we're going to do on transformations. I'm not going to give you an assignment on this because we've done transformations a lot. We just have to go back to the original notes here to be able to go through and do our transformations. So we have to be able to do all of these transformations with polynomials with degree higher than 2. So your assignment is to do the practice test. Now for those of you that aren't here to get the practice test, here it is. So what you're going to just do is pause this so you can get these done, so you can write them down and do it. So the first two questions you can see are on finding the roots of the polynomial. So remember, you have to set it equal to 0. Remember, when you find your numbers and you do your synthetic division, because it skips from x cubed to x, you have to put a 0 in. On this one, I gave an example of, remember that when we have a fourth power, we're going to have to do the synthetic division, get an answer, and then with our new numbers, do the synthetic division again to get it down to 3 so we can do it. This problem, remember, you're going to take the simplest polynomial function given these roots, so you're going to have to write the factors. Remember, when you have imaginary numbers or irrational numbers, that you have to have the conjugate. It's also in the factors. And then you can go through and you'll have to multiply that out. Here we have a story problem, in which case you have to find the length and the height. They tell you that the width is x, and they give you the information here. You have to find the length of x. Write your polynomial expression in the box. Set that equal to 0. Okay? Identify the possible rational roots. That's our plus or minus, the numbers we can do. Then find it, and then explain which roots will work for this problem and why. So again, remember, you should be pausing this so you can write these down so you can get it. This problem, you have to find the leading coefficient of degree and describe the end behavior. Remember, as x approaches positive infinity, and what does the graph do? And as x approaches negative infinity, what does the graph do? Then you've got here, again, using the graph. Now, we haven't covered the one a lot. I guess this, yes, the minimum degree. Okay. Remember the minimum degree possible. This is where all you have to do is look at the changes. So the number of changes, the degree has to be at least 1 more than that. So if you have 5 changes, the degree is at least 6. If you have 12 changes, the degree would be at least 13, and so on. So it's always 1 more than the number of changes. Then we've got the transformations. So there's 3 problems here where it goes from words to the equations. There's 3 where they give you the f of x and then they tell you what g of x is. The transformations written as equations, and you have to write the rule and then describe the transformations. So you write the new rule, what it would be if I did this to that function, and then describe the transformations. And then here is the graph where you move the points and you draw the graph. Then lastly, the answers to the problems. Okay, I've got all of them on here. And so again, you'll just want to pause this so you can get this all written down. And I'll move it so you can see the last part. And that's it. So there's 9. There's not 9 problems because you've got a 3 on a couple of these, but hopefully you won't have any problem with this. We'll be taking the test at the end of this week. That way, we'll hopefully all you have to do then is get caught up on any back work you have over break so that you can make up tests when you get back. So good luck on this, and have a good vacation if you're not at school this week.